Hey everyone, so I'm very excited to be as part of this community session with you through the AI Makerspace. So today I'm going to be talking with you about Haystack 2.0. So some of you I recognize from the last community session I did where I talked about, how Haystack got started with migrating from their 1.x to 2.0. And back in the day, I talked about some of the key building blocks. So for those of you who were in the session, just a quick debrief. For those of you who have not seen this, I think we'll get a chance to go over them. But essentially, I talked about some of the data structures and I talked about components as the building blocks of 2.0. I talked a little bit about the history of Haystack and how it led to this development of their 2.0 functionality. Fun fact, so over the winter or over December, they released this Advent of Haystack, which was a async Christmas event where they released like 10 challenges to give people a chance to work on their 2.0 functionality. And it was mostly an exercise in us, getting familiar with the 2.0 functionality and for them to discover bugs. So I don't know, what would you say was your experience like with it, Chris? As I know you've had a chance to play with multiple frameworks, what would you say was your experience like with 2.0?
Yeah, it was good. I mean, it is fairly straightforward to use. The syntax makes sense. The way it's set up makes sense. It is definitely a good alternative to some of the other frameworks. There's some friction still as it's working out the kinks, but for what it was, which is an early beta and kind of early access to their 2.0 platform before they're actually ready to launch it. It worked as you'd expect. So I thought it was a fun time and it was a good time.
So one of the things that I really enjoyed was having a chance to play with this idea of interchanging components. I think one of the areas that I found had more difficulties was when switching from the OpenAI providers to Hugging Face. And I think since they've implemented a few fixes, so the way they set it up is they released the collabs on a web page and then we could work on it. And they had a GitHub issue where you could drop your discussions if you have any problems or if you found any bugs. So I'm going to be talking a little bit about what that experience was like. So just as a quick, very, very quick debrief on how do we build RAGs with LLMs. Well, first, if you'd like to follow the slides, I'll put them, let me just put them in the chat. So you're welcome to follow some of these in here as well. But just as a quick crash course on this, well, first off, when we're building these RAG applications, there's this idea of building indexing pipelines, which is essentially the process of taking raw text and transforming it so that an LLM can consume it. When we're dealing with huge collections of text, either PDFs or web pages or markdown files, typically we have to go through the process of chunking it and transforming it into embeddings. This is typically a numerical representation that retains some of the semantic meaning. And then, we can go ahead and put them into a vector store. Popular ones include Pinecone or Quadrant or Milvus. And then once we have set up our vector store, we can connect an LLM to it. So in terms of, we move into what's known as a question and answer pipeline. Typically, we can use some programming languages such as Python to connect the LLM to a vector store through the use of APIs. And then, just as we processed our raw text into embeddings, we could do the same thing with a question from the user. We transform it into an embedding. And then when an LLM is asked a question, the LLM is going to go ahead and compare the embedding of the user question versus the embeddings on the vector store, and essentially is going to try to fetch the answer that fits best. Typically, when we're dealing with a user application, the user is not going to receive a numerical representation, but rather it should be receiving a natural language response. So in this case, we're kind of combining the capability of fetching information from a database with the generative capability of working with LLMs. Okay, so that was a bit of a debrief in terms of what RAG is and how we set it up. So very popular frameworks for building RAG applications out there include a LangChain and Llama Index. Haystack is another one of those open source packages that you can use for building LLM-based applications. They started off in 2018 as a startup, and they're based in Berlin. I think from the beginning, they had a very big focus on this idea of building question and answer systems using language models with a very strong focus on NLP production-ready applications. In terms of what we can do with Haystack as an open source framework, well, first off, it's written in Python, and its focus is on building LLM-based applications for production. They have a very strong focus on reproducibility, and their specific focus is on advanced retrieval augmented generation workflows. So since the beginning, they've been working with this idea of pipelines, where we have different components or different pieces in the pipelines that we connect together through code. And some of the key building blocks include, of course, being able to connect your pipeline to a database. At the beginning, they would work a lot with Elasticsearch and in-memory retrieval. Before the explosion of embedding providers, typically they would work with more classic retrieval techniques such as BM25 retrieval, which is more based on keyword similarity search. And as the field and NLP advanced and we had access to not just more advanced and more capable LLMs, but also better embedding methods, they started to adapt to this idea of, maybe let's make our components more adept to handling the changes. So the idea for them is, how do we navigate document sets? How do we navigate document sets that are of type PDF or Markdown or website while integrating with other providers? So you can sort of think of it as a framework to plug and play into your pipelines. So as I mentioned, for Haystack, so this is an open source package that you can install with pip and conda. At the moment, you can streamline experimentation with different providers. We can work with models from OpenAI, Cohere, and I think they just added an Amazon Bedrock integration not too long ago, as well as Hugging Face. They have a very strong focus on reproducible pipelines and scalability. So one of the ways that we can expand our pipelines is, once we have our pipeline in Python, maybe we want to schedule it on the cloud. So they work with this idea of serialization through YAML files. In terms of evaluating answers, they have built-in capabilities for assessing the answers via scores in the context. And deployment, I think from the beginning, they focused on deploying the solutions through their REST API. So I got a chance to learn more about Haystack last year through a collaboration at work. And I kind of had a chance to learn about it when they were still at the 1.x days. And I quite liked the way they think. So my background being more in data science and mathematics, I think I really like this sort of pipeline / systematic way of approaching things. I think it for some reason it struck a very personal chord with me, and I kind of became very fascinated by the way they were handling sort of these different components through pipelines. So I started, following a little bit what they were up to and what they were doing, and currently, I'm writing on this 2.0 release, which I'm hoping to release sometime in the next few months. So, well, I'll share with you today is, some of the result of me playing with Haystack 1.x versus 2.0, and then also playing a little bit with their advent of Haystack exercises. So, as I mentioned in December last year, they released this idea of the advent of Haystack, which was just like a 10-day exercise where they would release a collab with some code snippets, and then we would complete it. They had some GitHub discussion where we could post our solutions or post our doubts, or if we have any issues and we find bugs. And just a few days ago, they released the solution. So I'll be sharing links with you for those. In terms of how Haystack thinks about building RAG systems, they typically think in terms of data structures, components, and pipelines. These data structures include text, tabular, and byte. So for instance, if you want to build a RAG for your PDF or image files, they typically manage the bytes, a byte data structure. And if you want to handle something like audio and video, they have streaming data structures. So the components, so if we're thinking about a pipeline, when we think in terms of data science and we're doing more the classic data processing, we have maybe a table, or we're making a call through an API, and the data might be dirty, so we might clean it, we might rename the fields, we might deal with the null values, etc. We might then do some data analysis, visualization. And then if we have an application that has some ML attached to it, then the next point is to build an ML model, perform some evaluation, perform maybe Q&A testing, etc. And then, once you are happy with your prototype or happy with your product, you package it into some kind of application, maybe an API, and you put a user interface in front of it. So I think they have a kind of a similar approach when it comes to NLP-based applications, where we have these components, and these are just class-based units of code that perform specific functions. So for instance, if we remember the crash course about building RAG pipelines, we start off with a bunch of text, and I can't just, dump the files as they are. I have to pre-process them. So I'll have components for cleaning the files. I'll have components for transforming the files into vectors. I'll have a component that writes those vectors onto a database, and I'll have components for retrieving the appropriate vector out of that. So these components, you can think of them as like very specific or class-based units of code that can satisfy each of those functions. And then I can connect my components through the use of pipelines. So one of the key features of this 2.0 beta release is, they want to enable this idea of directed graphs, but also directed multi-graphs, where I might have pipelines that loop. I might have pipelines that move in one direction. I might have a component that runs on its own on a regular basis, etc. So they kind of thought about how do we break down the code so that it can meet the minimum requirements while still being able to scale to more complex applications. So as I mentioned, in terms of the data structures, typically one of the key features of Haystack when it comes to working with RAG pipelines is this idea of the document store. So the document store can be as simple as an in-memory document store, or it can be an integration to a NoSQL database or a vector database. So they typically will have some kind of integration where you can call the document store, and then you can store your text or your files as Haystack documents. So when I talk about a document here, this refers to a Haystack data structure that is encoded as a document that contains the information. We'll get into documents a little bit down the line. So 3 types of Haystack-friendly documents include the text, tabular, and byte stream. So this can be either an image or a PDF. For things like streaming, if you have video or audio, or if you want to simulate chatting with an LLM, they have streaming chunk and LLM chat messages. These ones we cannot store as documents, but they more provided the structure so that we can manipulate them as we need through our code. And then, of course, because they're focused on RAG, they created data structures for the question and answer systems. This include the answer data structure, the extracted answer, and the generated answer, which we then use to compare whether the LLM is getting the answer right based off of what is extracted from the text. So some of you might remember this diagram for the last time. If you don't, I'll just go through it very quickly. So remember that in Haystack, the key components are the data structure, or the key building blocks are our data structures, which include the document store with the document, the byte, and the byte stream. We have the data structures for Q&A, and then we have the components, which are just class-based units of code that satisfy a specific task within a pipeline. We have our data processing components for cleaning, splitting, caching, converting format, converting audio to text, and classifying language. We have components for transforming text into vector format through the use of providers. We have components to write the embeddings onto a database or document store. We have components to retrieve the information from the document store. We have components for ranking, components to integrate an LLM through providers, and then routing, which we can do, for instance, if we want to create a pipeline that branches. Let's say that we have documents in different languages and we want our pipeline to process each differently, or if we have documents of different types and we want our pipeline to do specific pre-processing on the different types, but then still bring the processed documents onto the document store, we can use routing for both of these use cases. Okay, so that was just a bit of an overview for more or less what I got a chance to cover last time in the last community session. So I now get to talk to you about the advent of Haystack and what it looked like to build some of these pipelines through their 2.0 beta release. So they had about 10 challenges. I think they had a very strong focus on introductory code, basically get us familiar and comfortable with what the new functionality looks like, while at the same time maximizing the opportunities for things to break. And I think I definitely had a chance to feel quite a bit of this during the first few days. Particularly when I was going from, I want to play with an OpenAI LLM versus a Hugging Face-based LLM. So I think in terms of the advent of Haystack, it was a really, really good exercise, both for us to get familiar with the new functionality and what it's going to look like, but also for them to get feedback from the community in terms of what's working well and what needs a little bit more polishing. They released challenges, and we started as simple as, build a RAG application where I am extracting information from a website, populating a document store, and answering questions about it. They gave us exercises on how to craft new prompt templates, and I'll get into what the new prompt template looks like. They covered a few exercises on how to create a pipeline with branches. Again, if your documents are in different languages or different formats. And then, as the time goes by, we start looking into, how can we use metadata to filter the documents? For instance, if your document has information pertaining a version, or if your document has information pertaining, a specific tag, we can use metadata to filter that. And then towards, I think, day 7, 8, 9, and 10, things started to get a little bit more interesting. Where we can start building conditional RAG systems. We can start looking into building custom components. And within the idea of custom components, they gave us this decorator called add component, where all we need to do is add an init method and a run method, and we can incorporate our custom component into a Haystack pipeline. So I'll get a chance to show a little bit in terms of what that looks like. They gave us a sneak peek into transcribing audio. So I had a chance to work with their Whisper integration. And then I think the more interesting one is, once you're thinking about productionizing this or moving this away from Python, they have built-in methods to transform your pipeline from Python into YAML format if you want to migrate or if you want to continue working and scheduling from here. In terms of how I see the challenges, I kind of interpreted days 1 and 3 as learning to set up RAG pipelines with different LLM providers. Days 4, 5, and 6, and 7 are more specialized use cases, where you can do branching, process different files, or do conditional RAGs. And then 8, 9, 10, I think was more about building your own customization and going beyond just Python scripts. So, okay, so just a quick overview of the components. So we have data processing components, embedding components, writing components, retrieval components, rankers, LLM generators, and routing. So I'm going to show you some code snippets in terms of what it looks like in 2.0 to put these together. Okay, so this is some snippet for a RAG pipeline that extracts content from the internet, populates a in-memory document store, and uses embeddings from Hugging Face to embed the results from the internet. So in this case, we're using Haystack-AI as the library where they're keeping the 2.0 beta release. And you can see here that we're using the pipeline. From document stores, we're using in-memory document store. If you wanted to use something like Elasticsearch or another 2.0 friendly vector store, you can just call it as is in here. And then these would correspond to the different components in Haystack. So in here, typically they'd go haystack.components and then the category of the component. So for extracting information from the internet, we can go to fetchers and ask for the link content fetcher. Because, if we extract information from a website, obviously the format we're going to get is HTML. So they have this pre-built HTML to document converter, and this HTML to document converter is going to extract the HTML page and transform it into a Haystack document class. And then from here, once we have transformed it into a document, we can start processing and embedding it and writing it. So this right here is a workflow or an implementation for an indexing pipeline, where I initialize my document store, I initialize my components. My components are the link content fetcher, the HTML to document component, document splitter, a sentence transformer document embedder. So this is what's going to transform my text into tokens and then embeddings through a model. I didn't specify one here. They use sentence transformers by default. So if you want to add that, I think you can visit the documentation and pick a different provider. And then from here, we have a document writer, which is then going to store our embeddings onto the document store. So we initialize the components, and then to initialize the pipeline, right now they have these two steps where we initialize the pipeline and we add components to the pipeline through this name and then the variable. And then we connect the components in a specific order. This order, as it turns out, is very, very important. So if I try to go from link fetcher to writer, that is not going to work because the link fetcher is going to give me a byte stream response from the HTML page, and the writer is not going to be able to interpret that as it's expecting a Haystack document object. So you could go from link fetcher to converter in writer if you didn't want to embed them, but we add this splitter and embedder to tokenize and transform our document into vector format. And then once we have added each of the components independently, we sort of connect them together. So link fetcher goes to converter, converter goes to splitter, splitter goes to embedder, and embedder goes to writer. So this gives us the entire indexing pipeline workflow. Now, in terms of what the question and answer pipeline looks like, so this initial workflow that I showed you here is just for getting raw text onto a document store with embeddings. So the next step is going to be, well, if I want to ask a question, I now want to build a question and answer pipeline. So in here, we're going to use sentence transformer text embedders. So the one we used before was sentence transformer document embedders. So this is going to be for our collection of documents. This text embedder one is going to be for the user question, so that the user's question is also embedded so that when the LLM is comparing for results, it can fetch the most appropriate response. In terms of the retriever, I'm using an in-memory embedding retriever because I am using an in-memory document store. I think as of today, they have released an open search document store with an open search retriever and an Elasticsearch one as well. So you sort of have to pair those two up. And then for integrating the LLM into the pipeline, they have this prompt builder and then a generator. So this generator in here is a GPT generator for working with models from OpenAI. For Hugging Face, they have this Hugging Face, I think it's HFTGI inference generator or chat generator. And I'll share at the end of this integrations if you want to work with Amazon Bedrock or other providers. From here, we can create or craft our prompt template. So typically we'll have our instructions and then to parse through the documents, they have this Jinja template formatting where I can iterate through my documents and I can access things like the content of the document, but I can also ask my prompt to go through the metadata of the document. I end my for loop and then I have my question. So I can build my prompt through the prompt builder where I pass the string. I can then initialize the components for embedding the user question, the component for retrieving, and the component for the LLM. Once more, I add each of the components independently, and then I connect the components to each other. So in this case, I can connect my query embedding to my query embeddings retriever, my retriever documents to the prompt builder documents, and the prompt builder to the LLM. So yeah, so just as a quick note, I think that's one of the big differences between 1.x and 2.0 is this idea of iterating through different documents and then iterating more granularly through different tags within the document. So this doc.content assumes that you're passing a Haystack document class. Otherwise, this is not going to work. So the Haystack document class will have both content and meta. They have other tags if you want to work with tabular information or byte stream based information, but you can just iterate through those in this. And then to run the pipelines, in this case, remember that the indexing pipeline was going to take as input a URL. So it's going to extract the content of the URL, it's going to clean it up, it's going to, well, extracts, transforms to Haystack document, cleans it up, chunks it, embeds it, and stores it into the document store. So when I run my pipeline, I say, okay, the data for the link fetcher is just, it's going to be a list of URLs, and I can pass the URLs in here. I execute that. The content of the pages is going to be saved onto the document store as embeddings. And then once I want to use my Q&A pipeline, I can do pipeline.run. I can pass my question. I want to make sure that I embed it, and I pass my question as part of the prompt builder as well. So that gives me the response. The other thing that they're giving us is this mechanism to easily draw the flow of the pipelines. So they have this pipeline.draw method in which I can sort of see the entire workflow and sort of the data structures and everything that I have available. So for indexing, I can start off by taking my raw text, embedding it through the sentence transformers text embedder, retrieve it. Oh, I think I got these two the other way around. Sorry, this is my indexing pipeline and this is my question and answer pipeline. Apologies for that. So this one right here is my indexing pipeline. So I start from a URL, I extract the information, it returns streams, a byte stream type data structure. It converts it into a Haystack document object. And from there, I split it, embed it, and write it onto my document store. And then for the question answer one, I will receive a question from the user in raw text. I will embed my question. I will then go and retrieve the appropriate information using the embedded question. And then from here, the next thing is the pipeline is going to run through my documents. And based off of the instructions that the LLM has received through the prompt builder, it can fetch the information. So if my prompt says, I want you to summarize based off of the information that you have, or I want you to, extract the most important information, et cetera, that'll be this prompt builder. And then the LLM just goes and performs the action. This is the generative part of the RAG system, and then extracts the information through a data structure that contains a list of strings and metadata. We can now start. So just to say, yeah, so I think that's it in terms of, the first 3 or 4 days of LLM pipelines as DAGs and MAGs, I guess if we want to talk about multi-graphs. The next category of challenges, I think, was more focused on more specialized use cases. So again, the format is always going to be the same. I initialize my components, I initialize my pipeline, I add the components to the pipeline, and then I connect the components to one another. So this specific use case is more geared towards classifying documents based on language. In this case, I have this component called the document language classifier, who has a job of classifying documents based off of the language. These right here are using ISO codes for the languages. I can set up my router routes through the use of dictionaries. I think that's another thing that is quite prevalent in 2.0 is the use of dictionaries/JSON objects for processing data. I can set up my metadata router, and then I can write the documents in different language based off of what I need. So in this case, I'll have a document store for each of the different languages. So this particular pipeline is going to receive a document in one of 5 different languages: English, French, Dutch, Spanish, and I think this one is German and this one is Dutch. So it's going to receive documents in 5 different languages, and the pipeline has the job of putting it into the correct document store. So I will have one document store per language, and the pipeline should correctly store the document onto the appropriate document store. From here, I can initialize a language classifier pipeline. And again, this one wasn't focused so much in terms of doing the cleaning, chunking, and embedding. This one was more focused on, let's just keep it simple. Let's just put it on just based off of language. Of course, if you want to add more components for chunking and embedding, you can add these as components. And then from here, we can connect them. So one of the things that I think is quite neat is we have sort of these sub component nodes or like not methods, but for instance, we see here we're going to go from language classifier to router, and then we have router.en. So we want to make sure that the router.en is going to en writer. So that is the document store, or sorry, the document writer in English. So router.en is going to make sure that it's going to write all those documents in English onto the English document store. We do the same thing for documents in French, Dutch, German, and Spanish. Other specialized use case that they released through this beta release is the use of metadata. So this is what a Haystack document looks like. I have my document, I have my content, and I have my metadata. So in this case, if I wanted to write them raw, I could do this, or if I wanted to write them through code, I could programmatically add my metadata through the use of the document object. And then to filter or to retrieve information based off of metadata, they added this filter key on their dictionaries. So in this case, I have a pipeline, and I didn't add the whole thing, but I'll add the link to the notebook. So in this case, I'm going to write a pipeline whose job is to extract information based off of specific metadata. So I can run my pipeline with the retriever where I'm asking a question and I'm applying the filters field meta.version. So in this case, I'm going to look for Haystack versions that are exactly equal to 2.0. So when I ask a question, it should only be retrieving information from this specific document. Other specialized use cases. So we saw routing through languages and we saw metadata search. The other one is route or process documents based off of the type. So before we saw a case where maybe I have documents in different languages and I want my documents to be saved in different document stores depending on the language. But sometimes I might say, you know what, I actually want the same document store, but I do need to process each document differently. So if I have plain documents, PDF documents, and unclassified documents, and I want to do the same processing, but obviously, well, not the same, but I want them to end on the same document store, I can use file type router to ensure that they're getting the appropriate treatment that they need. So, and then from there, we can process through their text file converter, process through their markdown converter, or process through their PDF converter. And then once they have been processed, this processing means I'm going to convert them from TXT, Markdown, and PDF into Haystack document objects. And from here, I can join them, clean them, split them, embed them, and write them onto a document store. The last piece is more around this idea. Okay, so they have these sort of predefined components that I showed you through the different categories. But of course, I think one of the things that the Haystack team realized is, we can't cover all possible use cases. So what they decided to do was to give people the opportunity to build custom components. Through these custom components, you can define them as a Haystack component through their component decorator. And the only thing that you need to do is to define it as a class. And there's two mandatory methods that you want to have, the init method and the run method. In here, you can specify the output type. So if let's say that in this case, what this is doing is going to rank documents via a date. And so in this case, what makes sense is to define the run function as a function that returns a list of Haystack-based documents. So in this case, you can just define your function. In this case, I just have a sorted function that sorts my documents based off of a specific field. In this case, it might be the date field. And I can just return my Haystack documents. So in this case, this custom component is built with my own logic in mind. I've had a chance to build components for processing JSON files of a specific structure. You can use components to process accessing data from SQL database and incorporate into your RAG system. And then the nice thing about this is once you have defined your component in this way, you can then connect it the same way that you would connect predefined components, where in this case, I'm going to go ahead and initialize my date ranker. And then I can add it to my pipeline. So in this case, I have my component, called recentness, where I pass my date ranker. I have my prompt builder and my LLM. And in this case, I'm going to connect the recentness documents to the prompt builder documents, prompt builder to LLM, and then I can run the question. I can ask any question that I want on the documents that I want. And so this specific pipeline is going to take as input so some file that is not of type Haystack document that has a field with a date in it. It's going to sort the documents based off of that date. And in this case, this looks like a question and answer pipeline. So then it'll answer questions about it. The last thing is this idea of converting pipelines from Python to YAML format and vice versa. So sometimes, especially when you're dealing with scheduling or productionizing your pipeline, you might want to move away from working with just Python files, and you might want to start creating layers of abstraction a little bit and adding schedulers. Let's say that you want to schedule this on a cluster, or you want to deploy it on a specific cloud service. So we can dump the content of the pipeline through their dumps method. This will produce YAML code by default. And in here, it'll tell me which components I used. In this case, I have a converter, a fetcher, an LLM, and a prompt builder. And then it'll just dump that for me into YAML format, and vice versa. If I have a pipeline in YAML format, I can convert it into Python. So if you're curious to take a look at the different challenges, or the different solutions to play with it, they released the solutions just a few days ago. So you can play with each of the different aspects of 2.0 beta. I think they're still receiving feedback. So if there's something in here that you say, hey, I have a use case for this, but the solution isn't working great for me, or there's something that can be improved, of course, I think they're very happy to receive feedback on GitHub or through an issue or PR. So you have access to the link through the link on the slide. Oh, and I totally missed, there was a question. So I'll get to questions at the end. Yeah, so the last piece is, and I'll just exit my screen for a little bit. So part of what they're actively maintaining is this idea of integrations. So if I go, let's just move this out of the way. If I go right here to integrations, this is sort of where they keep a list of all the different providers that they currently have an integration with. Anything that doesn't have 2.0 is currently only working for 1.x. So if you wanna, let's just take a look at the 2.0 beta. We can take a look at different model providers. So for 2.0 right now, you can connect to models from Amazon Bedrock, here, Google AI, Google Vertex, Gradient, Hugging Face, etc. So you can go and pick your provider. They added an Ollama integration recently. So if you want to work with Ollama, you can start working with some of these large language models locally. We have custom nodes. So again, this idea of a custom node or a custom component, you can go and define a custom component that specifies a very specific function. And then if you're interested in maintaining that, you can release it for the community to use it. For agent tools, I don't think they have anything. Monitoring didn't have anything. And then for document stores, for 2.0, right now they support Chroma document stores, Elasticsearch, Marco, Quadrant, Pinecone, and OpenSearch. I think for 1.x, I think they only have Milvus as the only one that they support. So over time, they'll be adding more and more document stores. But the point being is you can sort of take a look at, let's say we go to Chroma document store, we can take a look at how to integrate that. So in my pipeline, you saw me using this in-memory document store. I would just change that to Chroma or whichever document store I pick, and then I can just connect it to my pipeline. And the last thing, so just a few final thoughts. So this was, I think, their first opening to the community on how to work with Haystack 2.0. So what they had a chance to share through this beta release was this idea of connecting the components through pipelines to build multigraphs. If you have any questions or if there's something that you'd like to ask, I think one of the big questions that's going to come up in the next few weeks or months is migrating from 1.x to 2.0. And so if you are curious to chat with the team, or if you have any questions about integrating RAG through Haystack, they maintain a Discord channel. Typically they'll host office hours on the regular, I think once or twice a week. Every time there's an announcement, they post it there. And then also if you have any questions about any functionality or something not working, their dev rails are typically really, really responsive and very happy to help out. So I think I'll stop the share for now.